Does your voice AI agent has emotions involved into that? When we talk to human, there is a connection which is emotionally connected. The way that human speak, the other human understand is basically the tone, the emotions, what user want to say. We have seen all the voice AI agent being converted, the voice into text and text into again voice. So that's the pipeline that we have seen. But that is lacking the emotion what user want to say in their sentence. Hi, myself Nishant. I am CTO and co-founder at Codiste. In this video, I will walk you through the voice AI pipeline, which is a voice-to-voice pipeline. In previous video, we have seen like voice-to-voice pipeline, which has a voice-to-text, text-to-voice conversation. In this video, I will walk you through voice-to-directly voice conversation. Let's get started. Okay, great. Let's get started. So far in the last video, we have seen if you are building a voice AI pipeline, then the first module is a in the voice input that goes to speech to text. Then it goes to LLM, and then it goes to text to speech, and then basically again voice as an output comes in, and that is comes as a speaker as an output, so a user can hear that, right? So this is the whole pipeline that we have seen. Now what is the problem? The problem statement that I have seen in this is majorly, so the major problem that I have seen is whenever a voice that comes in and that it converts into text, we lose the emotions. So let's say if I was speaking with the sad or anger, the biggest problem is if it's converted into text and then LLM don't know what exactly the emotion looks like. So the first solution that comes into mind, okay, keep a emotions detection library, but the emotion detection library again will work on the transcription. But user's voice has the tone, the exactly specific, I would say, the emotion they have, which cannot be detected, I would say, by transcription. So that's where the problem starts. Now the solution. How about this, right? So let's say if voice comes as an input and it fades to LLM as a voice and then output also a voice. So this is called a voice to voice pipeline. Make sense? So this is exactly going to solve the problem of latency, and it is going to be the solution for, I would say, the emotion understanding. So exactly we have a narrative of what LLM has to respond and in which specific emotion as an output as well. So it's a more of a nature, how one user speaks to another, how a human to human understanding is like, okay, if I'm a sad, then the other person understands the feeling of the sad. Over here, that was being converted into text, so there was no emotion being passed from user to LLM. And that was the reason that it feels a bit of robotics as well. And then there is a latency as well, right? To solve this particular problem, there is another pipeline called voice to voice pipeline. So I will walk you through how it works and what are the modules that is being integrated as part of the voice to voice pipeline, right? Okay, perfect. So this time I have made a specific diagram, so at least you can understand. So let's consider. So there are total 4 modules in this. Step 1 is encoder. The output is vocoder. Consider like this part is speech to text, just for sake of understanding, and this vocoder is text to speech. Previously, this was converted into text. Now anymore, it is not going to be converted into text. So I will walk you through exactly the pipeline modules, right? So consider like a user speaks, hi, I want to talk to Mark. Let's say the word is in the end, hey, I want to talk to Mark. In previously, it was converted into text, so LLM doesn't understand the emotions. In this case, what we are trying to do over here is like, let's say this is an encoder. What encoder does is basically, it has a speech to text kind of functionality. What it does is, it is not converting into text. What it does instead, is, let's say a voice comes in, it converts into vectors. These vectors are a voice vectors. It has emotions and it has a meaning. What I meaning that, and what exactly user is trying to say, and the emotions as well, the tone, what kind of tone and speed it is coming up with. So that's the what exactly the encoder does. So what it basically does is basically converted the particular raw audio into data vectors. So these are data vectors that comes as an output. So this data vectors goes into adapters. Normally this data vectors can go directly into LLM as well. Now question, is this the same LLM that we can use, that we have used in OpenAI, that we have used into voice to text and text to voice pipeline? No. This is specific different kind of LLM. What I mean by that, the LLMs, so it is basically, this is an LLMs which can accept voice vector as an input. Normally, like OpenAI models, let's say GPT models, we don't have a full control because we don't have a weight. So we cannot change as an input. What goes as an input? Why? Because we don't have a modification options. So that's why what we can do is we can use Llama Omni models. Llama Omni models is specifically voice to voice models. You can input that as a voice vectors, the data vectors, and then it goes to LLM, and then LLMs basically convert that, gives output as a again a text, or I would say a voice vectors. Normally it gives us a voice vector whatever we need, and then those voice vectors goes to Vocoder. So Vocoder converts those voice vectors into speech. Right. So let me again explain you and what is the use of over here the length modality adapters as well. So over here the speech basically comes as an input to speech vocoder, comes into speech encoder, that speech converted into vectors. As these vectors are normally of the high in the length, let's say longer in the size. So this modality adapter basically convert that into LLM compatible length. So consider like it's a larger length, it converts into small chunk of length and then feed that into a large language model. This large language models like Llama Omni, make sure we cannot use OpenAI GPT models currently as of today. In future, they might accept the voice vector as an input as well. Yeah. And then as the next output, it consider again as a voice vectors. And this voice vectors converted into speech. Yeah. So what is the benefit of this? So the benefit of this first is low latency. The second is emotions being passed through the pipeline. Now obvious question comes into picture, does this LLM can accept our prompt? Yes. So LLM input is voice vector plus prompt, that goes as an input to particular this large language model, right? So I will again kind of say voice comes as an input to encoder, it converts the length into specific length that large language model accept. Inside the large language model, this voice vectors and the prompt goes as an input, it gives output as a voice vectors, and vocoder basically convert that voice vectors into speech which user can hear. Yeah, perfect. So that's how exactly it works. Now the limitations, right? Limitations is less accurate in tone calling. The problem statement is in the real-time world, in real world, still there is text to STT, LLM, text to speech. This is the pipeline that has been deployed in almost all the use case in the real world that I have seen so far. It can be implemented with the voice to voice, but as I mentioned, like when there is a tool calling comes into picture, there is a low accuracy, and also you have a less control of the prompt as well. Yeah. So perfect. So that's the pros and cons, and that's how the voice AI pipeline works. If you do have any question, feel free to ask. Thank you so much. Thanks for watching this video so far. Hope you get the insight about voice to voice pipeline, when to use voice to voice AI pipeline and when not to use it. If you are building a voice AI pipeline or voice AI infrastructure, and if you need assistance or if you need a development team that can help you to build that particular infrastructure or get involved into your current team, we are more than happy to collaborate with you. I have attached my Calendly link in this video. Feel free to reach out and have a consultation call. Thank you.